Okay, so do you guys want to get started? Yep. Okay. Let me share my screen and get going. Okay. Okay. So, welcome everyone. Welcome to Sig Ai's Let's Talk. Are you guys able to see my screen? Because I think it's kind of glitchy.
It's slow.
Slow?
At least
Okay.
for me.
Yeah, it's a bit slow, but
I can see a Sig Ai presents. That's it.
Technical difficulties, huh? Okay. Is that better?
Yep, that's better.
Cool. So, welcome everyone to Sig Ai Let's Talk. And today's topic is just an introduction to AI and ML. It's going to be really short, hopefully. Yeah, so let's begin. I'm Bharadwaj, your host today. I'm a computer science and engineering major and a cognitive science minor here at UC Merced. I'm a junior, and there's my Discord over there. Feel free to just, um, text me about any AI stuff. I'm really, I'm always down to, talk about AI. Love AI a lot. And next year is Jairo.
What's up, guys? My name is Jairo Carrion. That's my Discord name. If you guys wanna message me or anything like that, contact me. I'm also the AI Sig co-lead. No AI. I'm in charge of the Let's Code workshops, which I will have one next week. It's about data cleaning and data visualization using Jupyter Notebook, Anaconda, Python, and other Python libraries. If you guys are interested, you can go to the AI channel and and the announcements and the ACM Discord. So yeah, and like I said, that's my Discord. So keep in contact with me.
Cool. Thank you so much, Jairo. So, what exactly is Sig AI's Let's Talk? So, Jairo and I came up with this new plan for the semester, and we wanted to make it a little different this time. So, Let's Talk and Let's Code are two different events in this semester, and a series of events that we will be holding each Tuesday. If you guys missed the general meeting, then you guys would have heard it there. But um, Let's Talk basically is a place where people can learn something. And when you come here, we don't expect you to know anything about what we're talking about. And that's the whole point of Let's Talk. Let's Talk is basically a place where you come to learn. Throw away your fear of speaking. This is a place for discussion. So we want to encourage you to start talking here about what we're talking about and based on the topic. So it'll help us learn more, right? Because I'm not perfect too. Even I'm learning every day. And I'd like to learn something you might know on the topic. So it's a place where everyone can benefit. That's why I feel Let's Talk is a great place for us to, talk about some things about AI and machine learning and get to know stuff, um, get to know more about it. So yeah, let's start. So yeah, let's talk and let's code. The workshop schedule, there should be a URL. Jairo, can you just put it in the chat for me? Yeah, so Jairo will be putting the link to you in the link to the workshop schedule in the chat. This will be a schedule for our Let's Talk and Let's Code workshops each Tuesday and what we'll be covering each week. I definitely would recommend you guys checking it out. It's a so you can, you know, um, make your schedule so that you can attend our workshops. And don't forget, Hiro and I will keep reminding you guys every week that in the end of the semester, we will be having a coding challenge on AI and machine learning, and we will be it's sort of like a competition. We'll get to more about that in the later days. But now let's just get started on what we're going to be talking about today. So today we'll be talking about the difference between artificial intelligence and machine learning, AI and ML, how to learn data science, and what are the different types of machine learning, and what is machine learning in the first place, and how does this relate to what we'll be covering in the future of our Let's Talk sessions. And we'll be ending it with some questions if you guys have them. So let's begin. So does anyone know what artificial intelligence is? Like, has anyone heard about artificial intelligence? What does AI what does AI mean? Anyone? Feel free to speak, guys. No one? Come on, guys. I'm gonna keep waiting here.
Isn't it just like how you make a program to make decisions for something without you having to do anything itself? It's just automatically done.
Yep. That's right. That's completely right. So basically, artificial intelligence, I can explain artificial intelligence in many ways, but just to make you understand it in 3 separate points for you guys to remember is AI is basically enabling a machine to think. So what does that mean? We don't involve in the machine's decisions. All we give it is data, and we allow the machine to think and do its tasks on its own. For example, self-driving cars, right? It takes real-time data of what's happening around it, so that it can move the car, right, really safely. And it does require a lot of training. AI is basically a baby, right? It needs a lot of data to train. Like you get better at math problems when you do a lot of math problems, right? So something like that. AI gets better with more data because it has to do stuff on its own. That's basically what AI is. Okay, so basically this is AI, right? If you guys see my screen here, I have some text and I can put it wherever I want. I can place it however I want. With good data and with a good training of your algorithm, you can do stuff like this. So I'll be honest with you guys, all these slides that you're seeing right now, I haven't done, okay? It's all thanks to my AI buddy here. So what I do is I go to design and I go to design ideas, and voila, look at that, right? There are so many different designs that I can choose from. And let's say I like this one, right? Look at that. That's basically AI in a second. So it saw what I wanted, and it saw how people like to design stuff. It saw that I had bullets, and it arranged it in a way that looks really good, right? So this is basically AI. Let's go back to the, yep. You see how beautiful that looks from before? Okay. So for all you definition geeks, artificial intelligence refers to a simulation of human intelligence in machines that are programmed to think and mimic their actions like humans. Like I said, you do more math problems, you get better at math, something like that. And the term may also be applied to any machine that exhibits traits associated with the human mind, such as learning and problem solving. Okay, so that's the definition of AI. You want to take a picture, go ahead. So what is the difference between AI and machine learning? Now, this can be a really tricky question, but does anyone have an idea about this? Guys should start talking. You know, I don't mind if I just cover 5 slides, but I'd really like it if people start engaging in the conversation. Machine learning is self-improving. Mm-hmm. What do you mean by self-improving? AI is static. Machine learning evolves. Are you sure about that? Are you guys taking a look at the chat?
Mm-hmm.
You guys can start talking. Unmute your mic. I want you guys to start talking. Some AI involves machine learning. See, this is the thing, right? We all are here to learn, and I want you guys to engage in the conversation. And thank you so much, William, for engaging in the conversation. I think from next time, Jairo, I think we should have, like, you know, some reinforcements, good reinforcements for people to start talking. We'll learn about that more in the coming slides. But more math. Yep. Artificial intelligence and machine learning has a lot of math, especially machine learning. A lot of math. Yep. Correct. So the difference between AI and machine learning, as it's rightly said, isn't this a part where AI collects the data to work around? Yep. It is. So artificial intelligence is basically a technique which enables machine to mimic human behavior, which we saw in the previous slide, right? Machine learning, in the other hand, is a subset of AI, which you can see here. In the picture, you see that machine learning is like inside of AI. So it's like a subset, right? And it involves like statistical methods to enable machine to improve with its experience, right? And we'll learn about deep learning too. Deep learning is something that comes with neural networks, which really mimics the human behavior, like how our brain works with different neurons, and how we take in data and how we think. That's basically deep learning. We'll learn about deep learning in the coming workshops. So let's go next. Okay. So let me annotate here. So basically, now you guys know what machine learning is, right? But what is data science now? It kind of looks weird. So we learned about artificial intelligence. Now then we knew that machine learning is a subset of AI. And what is data science now? So I have a really small diagram here that I really liked, honestly, and I want to share with you guys. So basically, to understand data science is an intersection of 3 different sets, right? So the first set is math and stats. Math and stats. And the second set is CS. And the third set is subject matter expertise. We'll get to more of this in the next slide. And data science is the intersection of all these 3 things together, because it involves a little bit of math and statistics. It involves a little bit of computer science and a little bit of subject matter expertise. Subject matter expertise can be anything related to the subject that you're implementing data science on. We'll see more about that in the next slide. And you see this intersection over here, this intersection of mathematics, statistics, and computer science is what we call machine learning, right? So remember, we saw just someone say that machine learning involves a lot of math. Yes, you're correct. Machine learning involves a lot of math and computer science. These two over here, these two intersections, the intersection of mathematics and statistics and subject matter expertise is nothing but research. It's traditional research. And the intersection of computer science and subject matter expertise is software. Our traditional software, right? Yeah, that's about it. So this is basically data science. Data science is like it's like the intersection of all these three things together, and that's why it's a really hot topic today. Data science is really hot because it is bringing all these things together, which is making human lives a lot easier, right? So this is exactly what I said in the last slide. Data science is the combination of expertise that can be very hard to combine. This means that, okay, when you talk about subject matter expertise, right, we're saying any subject. So just because data science can be involved, involve in any subject, that's why it's so hot in the market right now. Like, for example, right, this is a single cell RNA sequence being manipulated using data science, right? And you need, okay, so let's say you're doing this, right? I'm not from a biology background, so I don't know a lot about this, right? But this so this shows you that data science can be put into or implemented in any subject you want, and that's where the subject matter expertise comes in. Just with a little bit of computer science and mathematics, people are able to do wonders. That's why data science is so big right now. And that's basically what data science is. Okay, so now we learned about what data science is and what machine learning is and what AI is, right? And now let's go more into detail in machine learning, because machine learning is something that is very evident in our day-to-day lives. More than artificial intelligence, what you see around you, like be it Google Lens or any any product, like, you know, maybe taking pictures, right? All of these involve machine learning, right? And machine learning is something that people get mixed up with AI a lot. People say that, oh yeah, this software uses AI, but in turn it's using machine learning. The thing is, we have never reached a perfect artificial intelligence system yet. That's because artificial intelligence systems can think on their own, right? They can learn on their own. We'll get to more about that. So machine learning is divided into three different categories: supervised machine learning, unsupervised machine learning, and reinforcement learning. Have you guys heard about this before? Anyone? Machine learning, types of machine learning?
I have.
You have?
Yeah.
Cool,
Yeah, I've
cool,
heard of the
cool.
terms before.
Uh-huh. So what okay, so when you guys look at the terms, right, you don't have to know what it is. Like, what does it actually like pop in your head? Like, what does, when I say supervised machine learning, what pops in your head?
You can restrict on what the machine is going to do.
Uh-huh.
Like you can set restrictions on it.
Mhm.
Right. Yeah, that's a really good way to think about it. Yep. Any more people?
I think of
Hmm?
recommended YouTube videos that show up on your playlist, or whenever like all these YouTube videos you watch and you log in back in, like there's a recommended list there. So that's what I think about as machine learning.
Oh yeah, actually, I always keep watching YouTube, and then I don't like people coming in my on my account and watching stuff, because it literally pollutes my YouTube basically, because what's happening, right? As you rightly said, YouTube is learning from what we watch, right? So okay. So let's say you watch a lot of sports, and you watch a lot of short memes or something like that, right? So then YouTube only picks those kind of videos and recommends it to you. Let's say you watch something about let's say you watch a TED talk, right? Maybe I don't like a TED talk, and someone else watches it on my account. Then YouTube starts thinking, oh, this guy likes TED talks, so let me give him more TED talks. But I don't like TED talks, so that's where that's where I feel that I don't like people touching my YouTube. So okay, so what do you guys think about reinforcement learning? This might be a little confusing, but do you guys get anything in your head? Think about reinforcement learning.
It's like when you give the machine a positive reinforcement for something they did good, and then a negative reinforcement for something they did bad.
Spot on. You are spot on. So that is exactly what reinforcement learning is. You'll see that you're right in the coming slides. So let's just go. Yeah. Okay. Supervised machine learning, right? Supervised machine learning is one of the types of machine learning. I spelled learning wrong. Yeah, I gotta learn how to spell learning wrong. Learning right. Yeah. Okay. Let's just ignore that for now. But based on supervised learning is sheerly based on labeled data. What do you mean by labeled data? So labeled data is basically the data that has been given a label. Okay, let me make some sense here. So let's say I have a picture of a phone, right? This phone, if I just have a picture of this phone, the AI system or the machine learning model has no clue what this is, right? But if I do give it a label saying that this is a phone, or this is a paper, right? Then these labels help the machine learning model improve on what it sees next. So in supervised machine learning, we teach the model with different labeled data, only labeled data. So we use only labeled data, and we teach the model. Let's say, for example, I give the height and weight data for a person, for the model. It'll predict if another person looking at its height and weight, it'll be able to tell if the person is obese or not, right? So that's basically what what supervised machine learning is. Taking what it saw before, and only based on what it saw before, it's able to predict if something is if something falls in a particular category, right? Yeah, and we are always given past labeled data here. Okay, so this is supervised machine learning. What about unsupervised machine learning? Well, unsupervised machine learning, we don't give any labeled data here. So there is no labeled data. So it's as equivalent to as giving the model a picture of my phone, and that's all. And it doesn't know it doesn't know what it is. It can mistake it to think it's a remote, or maybe it's something else, but it's up to the model, right? I don't care. I just gave you a picture of a phone. Okay, I want you to I'll give you many pictures of phones, right? And I want you to tell me the difference, what you find. So how does this do this, right? So there's an example here on the screen. You see a picture of irises, right? They're flowers. Iris have 3 different types, right? Versicolor, setosa, and veronica. I think it's pronounced like that. But all these different flowers have different shapes, sizes, and they have a lot of things not in common. But they're all our irises, right? They do have some differentiating factor from them, but we don't tell the model that these are the things that differentiate them apart, right? It's up to the model. So we let's say we give it the petal size, we give it the color, and we give it the size of the flower itself, and how many petals it has. All these things are called features, right? Once we give this to the model, we don't say what it is. We don't say if it is versicolor, or we don't say if it is setosa. We just give it to the model. All the model does is plot it on a graph like this, right? This is petal width. This is based on the iris's petal width, and the model is able to identify that, oh, all these types of flowers have smaller petal length, and all these types of flowers have a petal length of 1.5, and all those flowers have like really long petals, right? So it's able to differentiate these. This is called clustering, right? So the model is able to cluster the different types of data it's given to differentiate between the flowers in this example here. So this is basically unsupervised learning, not giving any labeled data, and you're using clustering to find out the difference between each of these flowers in this example. Reinforcement learning. I remember someone said about reinforcement learning, and it was exactly what reinforcement learning is. It's basically like how you train your dog, right? So let's say you train the dog, saying that let's say you throw a stick and you ask it to get the stick back, right? And the first time when you throw the stick, the dog's gonna look at you and be like, dude, what the hell are you doing, right? It doesn't know what you're trying to do in the first time. Like if you throw a stick, the dog by birth doesn't know that it has to go get the stick. We train the dog to go get the stick. How? By giving positive reinforcements. We reward the dog by giving it a treat, or giving or doing something it likes, maybe being happy, because dogs can also sense human emotion, right? Maybe if the dog does something and then you give a happy response, it's more likely that the dog is going to do that again, right? So it's also that we also give them this is the same case with models, right? In reinforcement learning, all the different models are given positive and negative reinforcements. So what this does is that it tells the model, oh, you're going in the right direction, good job, or oh no, that's not what I want you to do, right? And here the difference between reinforcement learning and unsupervised learning is that here you are the model is given a little bit of labeled data, right? You do say, okay, do this. Okay, let's say this phone is this picture is called a phone, right? This is a picture of a phone. You just say that, and then later the model is gonna take a picture of a mouse and be, is this a phone? Oh, this is not a phone. Okay, so that's a negative reinforcement. Is this a phone? Right? Is it a stand or a phone? I don't know. Right? I'm gonna say no, it's not. Right? And it's gonna keep it aside. And finally, if you show if the model shows another phone and says, is this a phone? Then we say, yeah, it's a phone. Then it learns. It tries to correlate what it found from different phones, and it tries to see the similarity between it. So that's how the machine learning model learns in reinforcement learning. Okay, and for all you guys who know about AI, this is a question for you guys, right? And anyone can answer this, but do you guys know what the fourth type of machine learning type is? Anyone? I'd really appreciate if someone knows this, because this no, not deep learning. No, not big data. Come on. You guys can search online too. This is something that I really, really liked when I first saw it. You guys search online, go ahead. I think I think I only told this to Hyro. But Hyro, please don't answer. But rest of you guys, no, not virtual reality, no. Semi-supervised, kinda, but no, not the one I'm looking for. Hyro's phone. No, not yet. Come on, guys. What's the last type? There is one more. I'll wait. I really want to see who gets this. Let's wait for a minute. Let's see who knows. Who's the one who will find the fourth type of machine learning models. It's kind of new. It's relatively new. And once I tell you what it is, let me know if you guys want a separate workshop on it. I'll be down to teach you guys. It's really cool. Neural networks? No, not neural networks. Since we have a lot of time, I can wait for 2 more minutes. You guys can search online, search anywhere. What is the last type of machine learning model? There are 3 types. We learned about we learned about supervised learning, unsupervised learning, JavaScript. I wish. We learned about supervised learning, unsupervised learning, and reinforcement learning. What is the 3rd type of machine learning? Okay, so you guys have 30 more seconds and I'm gonna reveal it. Multitask learning. Never heard of that. Multitask learning. Andreas, right? Is that how I pronounce your name? Yeah. What do you think multitask learning is? Okay. Would you like to share with us what multitask learning is? Because I never heard of it before. Hybrid learning. Hybrid learning is something that I feel is a practice. A lot of people use hybrid methods, but I don't think it's a type of learning. Okay. No, not air gestures. Okay, so this is the 4th type of machine learning. It's called self-supervised machine learning. I don't know if you guys heard of this, but this is something really, really groundbreaking. So self-supervised machine learning is basically like a baby, right? So, okay, let's say a baby is playing with some toys, right? The baby knows that okay, so in the picture you see a small ring, right? Yes, it learns based on interaction. So what it does is that let's say the baby has the ring, right? It knows that the ring is in orange colored, and it knows that the ring is round. It knows how the ring feels. It knows how it looks like, but it doesn't know it's a ring, right? Like, does a baby know how what a ring is called before it learns how to speak? Like, it knows. It knows that the blue ball looks differently, feels differently, and is in a different size compared to the ring, right? but it really doesn't know that it's called a ball and it's called a ring. This is what self-supervised machine learning is. You leave the model to interact with the world, and it takes its own data. Okay, it takes its own perspective of the world, and it's able to differentiate between different objects and give it its own labels. That is the whole point of self-supervised machine learning, giving itself its own labels to just differentiate between each and every component. Deep learning, so deep learning is not self-supervised learning, but it's deep learning is how humans think. It's deep learning doesn't. Okay, yeah. So it may sound similar. I get why you're saying deep learning. Is it basically deep learning? But deep learning is, I feel, a method that is used in neural networks. So okay, so how did deep learning start in the first place, right? We always used to have like neural networks with only like one or two hidden layers, right? Okay, if you guys are really getting confused what I'm speaking about, don't worry. We'll be covering this in the coming workshops about neural networks, but I'm just trying to answer this question, right? So usually neural networks have only one or two or hidden layers before. But since computation power has increased, and since there was a paper that was published, which I will link to you guys, from when that paper was released, right? People were able to realize how to use the computation power we have currently to have more hidden layers. So basically, deep learning is passing the data through different layers, different hidden layers, to get a really accurate output of let's say a classification model or a regression neural network or classification, whatever problem you're working with. So to get a more accurate to get a more accurate prediction, we increasing the number of hidden layers is what deep learning is. But self-supervised learning, on the other hand, we don't do that. We don't do anything. Everything, see, at least in deep learning, we code the different layers, right? We code the different hidden layers, and we say, okay, do this here, do that there. But here we don't even say that. We just leave the model on its own. So it's there for interactions. It does what it wants, basically. So this is purely, I think the closest to AI we have gotten. But yeah, and definitely I'll link you guys the link to this. Do read about it. It's beautiful. It's beautiful. I really want to work in this field in 2 or 3 years. So really like this. Okay, let's continue. Self-supervised learning. Remember the name. It's really cool. Okay, and I think this is the last slide. So different machine learning models we'll be going over in this in the coming workshops, right? This is only in talks. So this is in AI talks. So so supervised machine learning has a different model. Like, so okay, so we talked about the different machine learning models, right? And all these machine learning models have different types. Sorry, we talked about different machine learning types. All these machine learning types have different machine learning models associated with them. So supervised, we will learn this in the future. And this is just a small overview of what we'll be covering. So supervised machine learning, as you learned, has 2 different types of models: regression models and classification models. The difference between regression and classification is that regression will be maybe having some computation and giving a number output in base cases. And classification models, on the other hand, are just segregating segregating stuff. Like basically, remember when we saw the example of saying if a person is obese or not. So if the person is obese, he goes in the obese category. If the person is not obese, that person goes in the not obese category according to height and weight, right? So this is basically one of the classification models. So segregating them into groups. Regression models include linear regression, decision trees, random forests, and neural networks. And classification models include logistic regression, support vector machines, decision trees, random forest, and naive Bayes classifier. And we'll be going over all this. Please take a look at our workshop schedule, and you'll have more information on this. And we'll also be going over unsupervised machine learning models. So like clustering, different types of clustering, and dimensionality reduction. Okay, so this is where you guys come in, right? I want you guys to tell me, because I really like your guys' feedback, and your feedback is really important for me and for us, for Jairo and I, as the lead of AI Sig. Well, we have given you what workshops we want to conduct, right? We want to conduct workshops on supervised machine learning and the different models, unsupervised learning, and machine learning and their models, right? What do you guys think? Do you guys would you guys like a workshop on self-supervised learning, or are you guys really happy or excited about this? How do you guys feel about this workshop and this AI talks today? What does PCA stand for? Dimensional reduction. I think, okay. PCA is nothing but principal component analysis. So dimensionality reduction is basically the process of reducing the dimensions of your feature set. So we'll learn more about that. I'm not going over in complete detail about all these, but it's up for the next coming workshops. So we'll be going over all these kind of different models, and for you guys to get a conceptual understanding of all these models is really important. So that's what I'll be focusing on. If you'd like, I can go in detail with the math, but I don't want to scare people away. So that's why I really want this to be more of an intuitive learning environment where you're able to connect the dots with really simple understanding. And then later with this conceptual understanding, you can go into detail with the math, right? So yeah, this is basically it. And these are some keywords that we use today. Let's just recap, right? We learned about artificial intelligence, and we learned about the difference between artificial intelligence and machine learning, right? And we also learned that data science was the intersection of math, statistics, and what was it? SME, subject matter expertise. I'm getting lost. And the third thing is computer science. So data science is the intersection of all these three sets. And we learned that. And then we learned about supervised machine learning, unsupervised machine learning, and reinforcement learning, right? And what was the last machine learning model that, machine learning type that we discussed about? Does anyone remember the name?
Self-supervised.
Yep, that is it. So self-supervised is the way to go. I really love self-supervised, and yeah, I think it'll be great if we all can have a workshop on it and discuss about what we learned about self-supervised learning, and make this a way to just go out there and try to learn and share what we have, right? We'll try to make a small community here to talk about. Okay, so now on to the questions. Does anyone have any questions of what we discussed? Okay, where is self-supervised learning used? You can use self-supervised learning anywhere you want. No, so basically self-supervised learning is used wherever you have when you don't have labeled data, right? Let's say we have a lot of pictures of people, let's say you have a lot of pictures of me, right? You can't you can't like go label each and every picture. Oh, this is Bharadwaj, this is Bharadwaj, this is not Bharadwaj, this is Bharadwaj, right? So it's really tedious to do that, right? Instead, you can use unsupervised machine learning where you don't have labeled data, and you can just tell the model, hey, look for patterns, okay? Just do your thing, right? That's where unsupervised machine learning is used. So did that answer your question? Yeah. Any more questions, guys? Any more questions? They're all open questions.
Yeah, I have a question about clustering. So you said when you feed like images to the program, it just clusters all the pictures into distinct categories, right? So then does it later go in to make labels for those clusters, or is that something you do manually?
Okay, so when it is so when clustering actually happens, I don't think it labels the data. I'll get back to you on this, but I don't think it labels the data. What it does is it just separates it into distinct categories, right? So what happens here is that, let's say, okay, let's go back to that slide, right? Oh, no, discard. It's okay. Okay, so let's go back to that picture, right? Okay, so here basically so the label is what it finds, what similarities it finds in the data that it's given is what the label is. So it decides what to take as a label, and it decides what to not take as a label. So basically here, petal width, right? Okay, let's say color, right? Let's take an example here. Look at the iris, right? I'll give you 3 different irises with 3 different with the same color, and so I'll tell you, differentiate between these 3 irises, right? What would you do? Would you say, oh, they all look this, they all have the same color purple, that's why they're 3 different irises? No, right? What would you say? You would say that, oh, maybe the petal length of this iris is shorter than this one, and this one is longer than the rest, right? So that's how you take a label that you like, which you feel will differentiate from the different pictures you're given. Yeah. So did that answer your question?
Yeah, it did. Thank you.
Yeah. No, I'm talking about unsupervised. Yeah, that's what I said. So unsupervised, that's what unsupervised machine learning does, right? So it is able to, you're still giving the data to the, okay, yeah. So the difference between unsupervised machine, okay, so I think you're getting confused here. So unsupervised machine learning and self-supervised machine learning, the difference between them is that in unsupervised, you're just giving the data to the machine learning model for it to understand what to take as labels, and where to segregate or to find patterns and to learn from it, right? But self-supervised learning, you don't give it specific data. You just send it out in the world and just say, go live, right? That's self-supervised learning, basically. Yeah. So any more questions, guys? Any more questions? Let me stop sharing. Yeah.
Do you have any like recommendations on resources to use to kind of get into machine learning on their own time?
Yes, I do. So how about I get back to you on that? Do you guys follow the Sig Ai or the channel, Sig Ai channel?
Is that the one on the ACM
Yes.
Discord? Okay. Yeah.
Yeah. So keep a lookout on that channel. I will update you guys on the self-supervised learning link. I'll give you guys more resources on machine learning and data science that you guys can go over, and she'll be really helpful. And do you guys like the idea of sending you guys some resources so you can just have a read about it before coming to the AI talk? So maybe you guys can start talking a little more. What do you guys think?
Yeah, I think that's a good idea.
Yep. Okay. Yeah. Yeah. That sounds good. Okay. So just keep a lookout on the AI chat on the channel of ACM and Sig ACM, and then we'll be sending you guys links and resources so you guys can take a look at what we're covering. Our marketing team is really on the go. Like they really helped me um, uh, get this event to everyone. Really thanks to them. And they'll keep letting you know when the workshops are happening. So just keep an eye on the announcements, and keep an eye out for the resources and stuff. Yeah, and thank you so much for joining this session with me, guys. It was really great. This is my first session, and thank you so much, Jairo, and our president, Jet. Yeah. Thank and Paula as well. Thank you so much, guys. Cool. Yeah, thank you so much. Yeah, that's really that's really helpful. Cool. Thank you.
For sure. I'm gonna stop the recording right now.
Well, you did record?
Yeah, I recorded it. We're gonna post it on our new YouTube channel actually.
Ooh, nice. That's